YouTube. Welcome back to Intuition. So it's that time of year. A lot of us, we try to get in shape for the summertime. So in today's video, we're going to be talking about weightlifting and weight loss. Stay tuned. In today's video, we're going to answer two questions about weightlifting and working out. This video should really give you a good idea of the amount of energy that it takes to lift weights and to develop a good exercise regimen. So with that said, let's answer these two questions. Okay, question number one. Question number one states, CJ bench presses 160 pounds at the gym. He does 3 sets of 10 reps. He also squats 250 pounds, also 3 sets of 10 reps. How much energy does he expend during this workout? His arm length is 34 inches, his femur length is 20 inches, and assume that he has a body efficiency of 20%. What is this question asking for? CJ is burning energy by lifting things. The amount of energy that he has to exert is going to be equal to the amount of work that he has to do to get this job done. And what's the equation for work? The equation for work is force times distance. Easy, right? Very simple equation. So we just have to calculate the force times the distance to get the amount of work done. And the amount of work done will be the amount of energy that he exerts to do the work. So let's go ahead and solve for the amount of work done. Let's start with the bench press. With the bench press, he's lifting 160 pounds. Now, what is that? The 160 pounds is the weight of the object, and the weight of the object is the force necessary to lift the object. That's what weight is. If you're going to lift something off the ground, you have to match the weight of the object, because the weight of the object is the force exerted by gravity towards the ground. And in order for you to lift the object, you have to counter the force of gravity to get the object from the ground to a certain distance above the ground. So the resistance that you face when lifting the object is the force of gravity. Therefore, the amount of work that you do to lift the object will be the force of gravity times the distance the object moves. And what is the force of gravity? The force of gravity is the weight of the object. But in this case, we're given the weight of the object in pounds. But on this channel, we're metric, right? So we're going to convert from pounds to newtons. Newtons is the metric unit for measuring force, not pounds. So we want to convert from pounds to newtons. There are 4.9 newtons in 1 pound. We take the 160 pounds, multiplied by 4.9, and we get 784 newtons. So that's the weight of the barbell in newtons. Now we multiply the force times the distance the barbell moves. Assuming that he doesn't do half reps, he's gonna do full rep. He's gonna take the barbell from his chest and extend his hands all the way through. So he's gonna do a full rep. And if he does a full rep, he will move the barbell a total of 34 inches because that's the length of his arm. Now, inches is not a metric unit. So we also want to convert inches into a metric unit. What is the metric unit for distance? Meters, right? Not inches. So we want to convert inches to meters. And how many inches are there in 1 meter? Approximately 39 inches in 1 meter. So we're going to take the force, 784 newtons, multiply by the 34 inches and divide by 39 inches to get the distance in meters. What do we get? We get a total of 683.5 Newton meter. And a Newton meter is equal to a joule. So that's 683.5 joule, and that's an energy unit. So that's the amount of energy that it takes for him to do 1 rep. But it says here that he's going to be doing 3 sets of 10. And if he's going to be doing 3 sets of 10, that's going to be a total of 30 reps. So we multiply this energy by 30 to get the total amount of energy for his 3 sets of bench press. Okay, so we multiply 683.5 times 30. That gives us 20,505 joules. Now we just got to do the same thing for the squat. He's squatting 250 pounds. The distance that he carries the squat, assuming that he bends his knees at a 90-degree angle and then he completes the squat when he's standing straight up, the distance that he lifts up the barbell is equal to the length of his femur. So we have 250 pounds. We multiply that by 4.9 to get the force in newtons. Okay, we got that. Then we multiply this force times the distance. The distance is going to be 20 inches, but we have to convert that to meters. So we divide by 39. We get 628.2 joules, which is the amount of energy that it takes to do 1 squat. Now he's going to be doing 30 reps. When we multiply that by 30, we get 18,846 joules. So we take the total energy for the bench press and we take the total energy for the squats and we add those together, right? We get a total energy of 39,351 joules. Now, are we done? Not quite, right? If you look at our answer choices are in calories, not in joules. We know that we're gonna have to do a conversion from joules to calories. Turns out that there's 4,184 joules in a calorie. So we take our total amount of joules and we divide it by 4,184. We get 9.4 calories. But we're still not done yet. And we're not done yet because of the last statement in this question. The last statement in this question states that the patient body efficiency is only 20%. The amount of energy that he expended to lift these weights is only 20% of the total energy that he actually had to generate to be able to get this work done. The body's conversion of energy is not 100% efficient. The body has to convert the food that you eat into chemicals, and then he has to use these chemicals to generate action potentials or electrical signals to be able to get the skeletal muscles to contract. And this entire process is not a 100% efficient process. We're being told here it's a 20% efficient process, which means that the amount of energy that it took for him to lift the weights is only 20% of the total energy that he actually expended. Where did the rest of the energy go? Well, it went into his body, his temperature went up. When you work out, you notice your body gets hot, you start to sweat. So that energy goes into heat, because remember from our thermodynamics video, entropy always increases. So there's always going to be some energy that is wasted. Okay, so to get the total energy expended, we just have to multiply the 9.4 calories times 5. We get 47 calories. And that's the total amount of energy that he expended during his workout. And the answer is A, 47 calories. He did 60 reps basically of lifting, somewhat heavy weights, and yet he only burned 47 calories. No wonder weight loss is so hard, right? If you're really serious about trying to lose some weight, you really want to lift a lot of weights, right? Because remember, energy expended is force times distance, and the force is the weight of the object. So if you spend a lot of time lifting light weights, you'll burn energy, but you won't burn energy as fast compared to when you lift heavy weights. So you want to lift heavy weights and you want to lift a lot of weights to be able to really burn a lot of energy. And the more energy you burn, the more weight you can lose as long as you restrict your calorie intake. So if you lift a lot of heavy weights and don't eat a lot of food, your body weight is guaranteed to go down. Losing weight is a simple formula. Your calorie expenditure has to be greater than the calories that you consumed. That's it. Okay, so with that said, let's go on to question number 2. Okay, question number 2. Question number 2 states, having been told that work is equal to force times distance, CJ is skeptical because this implies that he gets nothing out of his isometric hold exercises. Select the correct statement about CJ's concern. So he's just been told that the work that he does is equal to the force times the distance traveled. He likes to do isometric hold. What's an isometric hold? An isometric hold is when you load up a muscle with weight. So you have something heavy, you're carrying something heavy, but you're not moving it. If you're holding something heavy, but you're not moving it, according to our equation for work, the work should be equal to 0 because there's a force there because you're holding the weight, but if you don't move the weight, then the work done is 0. And how does that make sense? I mean, if you hold something heavy in your hands, after a period of time, you're gonna get tired. And it definitely feels like you're doing work. That equation that we just talked about seems bogus. So let's see if we can fix this concern. Let's look at the answer choices. Answer choice A says, CJ is correct. Force times distance for work is bro science and holds no validity in the real world. Okay, work equals force times distance is a proven concept in classical mechanics. That's definitely a true equation. It's not bro science, it's real science. Okay, so that's incorrect. Okay, let's look at the next answer choice. B says CJ is incorrect. He must move the weight across a distance instead of simply holding it if he wants to burn energy. So this answer choice is actually incorrect. We all know from experience that if we hold something heavy, eventually we're gonna get tired. Our muscles will fatigue. So we must be burning energy. He doesn't actually have to move the weight to burn energy. It almost seems like a contradiction because we're just being told that work is force times distance, yet I'm telling you that you can hold a heavy weight and not move it and still do work. Here's the catch. The catch is what you're doing work on. If you just hold a weight and don't move it, you're expending energy because you're generating the force. And remember, in order for you to generate a force, your body has to convert the chemical energy from the food that you eat into electrical impulses to cause muscle contraction. So that's going to take energy to do that. So you're burning energy, it's just that the work that you're doing on the weights is 0, but the work that you're doing on your environment is not 0 because you're heating up the environment. You're sweating, you're getting hot, your body temperature is increasing because you're burning energy, but all that energy is being converted into pure heat. And none of that energy is being converted into mechanical work, which will be the work that you will be doing if you're moving the object. So the barbell is not taking any energy from you. The environment is taking all your energy. So B is incorrect. So let's look at C. C says CJ is incorrect. Isometric holds require muscle contraction and constant action potential to counter the weight of the barbell. He will burn energy. Exactly. Yes. In order for him to be able to hold the weight, his muscles have to contract. And for his muscles to contract, that takes energy. So isometric workouts are not useless. Okay? And just to make sure that we're not making a mistake, we look at the remaining answer choices. D says CJ is incorrect. Skeletal muscle contraction generates a conservative force that always burns energy in a contracted state. This answer choice sounds reasonable, right? But what's the problem with it? The problem with this answer choice is that it says that skeletal muscle contraction is a conservative force, and it's not a conservative force. Because what's a conservative force? A conservative force would be a force like gravity, or a force like in a spring. So if you look at a spring, if you contract the spring by a certain amount, it always generates a constant force at that level of contraction. Our bodies doesn't work like a spring. If I'm going to pick up a chip to eat a chip, I'm going to contract my biceps, but I don't need to generate a large force in my biceps to eat a chip because the chip is lightweight. But if I'm going to lift, if I'm going to curl a heavy weight, I'm going through the same range of motion, but now my biceps is generating a much larger force to be able to lift the barbell than to curl a chip, right? Which means that the force is not conservative, because if skeletal muscle contraction was a conservative force, then the same force that my biceps generate to curl a barbell would be the same force that it generates to eat a chip, which would be crazy, right? You'll be basically smashing chips on your face, which would be a very stupid design. So the beauty of action potential is that we are given the ability to modulate the force generated by our bodies. So if I'm going to lift something light, I generate a light force. But if I'm going to lift something heavy, then I recruit a lot more muscle fibers, right? So it's not conservative. Every curl is not the same. That answer choice will be incorrect as well. Okay, so there you have it. I hope that you guys learned something from this video. I hope that you continue to learn and you continue to educate yourself. I hope that you're looking forward to getting back into the gym with everything opening back up and basically achieving that body and that aesthetic that you're looking for. So keep learning, keep watching. We release videos every week on this channel. So see you next week. Bye-bye.